Okay, so let's start today's session. I'm going to share my screen. I hope it is visible. So today we will talk about classical mechanics gate topic, and there will be 5 questions for today's lecture. Okay, and the classical mechanics, the first question will be from gate 2020, and let's start. So this is the question number 25 from gate 2020 physics question paper. Am I audible? I think yes.
Yes.
Okay. So I'm just going to start today's session. So this is 2020 GATE physics question paper, and it is the question number 25. The question is, if a particle is moving in a sinusoidal curve, the number of degrees of freedom of the particle is how much? I mean, what is the number of degrees of freedom of that particle if the particle is moving in a sinusoidal curve? Okay, so this is a simple. Okay. Yeah, so let me first start the session. There is some. Okay. So this is the GATE 2020 physics question paper, and we are talking about today's in the lecture we will talk about classical mechanics. So there will be 5 questions on classical mechanics. Yeah. Maybe it will be better to wait for some time, and after that we will start. Let me wait for 1 more minute, and after that we will start. Because people are coming still. So yeah, hello everyone, and this is GATE 2020 question paper, physics question paper, and today we will talk about classical mechanics GATE topic. And let's start. So this is the question number 25, and the question is, if a particle is moving in a sinusoidal curve, the number of degrees of freedom of the particle is which? I mean, what will be the number of degrees of freedom of the particle if it is moving in a sinusoidal curve? Okay. So first of all, I'm just giving some overview of that question. Like they are asking about the degrees of freedom. So to have the knowledge of degrees of freedom, we need to know how many number of constants are there and how many particles are there. So there is a expression between degrees of freedom and the number of constants and the number of particles. It is nothing but degrees of freedom is equals to 3 into n minus k. So what is n here? N is nothing but the number of particles. Like we are considering here only one particle. You can see in that question they are asking that if one particle is moving in a sinusoidal curve, so that means the number of particle for this case is 1. But in general the expression is 3n minus k. And what is k here? K is the number of constants. I will tell you what is number of constants. And this is nothing but the degrees of freedom, 3n minus k. Now for this case, in that question they are asking that there is one particle, and in this particle is moving in a sinusoidal curve. So let me tell you this curve is nothing but a sinusoidal. Oh, not that much good in drawing, but yeah. So this is nothing but a sinusoidal curve. You can see Why sinusoidal? This is a sine curve, because you can see here, if I am writing here x and here it is y, then let's say x equals to 0, pi, 2 pi, at that point 3 pi, these points will give a 0 value, and all other points will give the non-zero value, and this will give a pi by 2 maximum value of y or something. So this type of motion one particle will have. So if it is like that, then what will be the degrees of freedom for that particle? So first of all, for knowing the degrees of particle, we need to know these two. One is n and another one is k. So now for this answer, for this question, number of particle is nothing but 1. Right? Now coming to k value, what will be the k? Number of constants. So you can see the particle is moving in a sinusoidal curve. So in sinusoidal curve means there will be some expression between y and x. What is the expression? The expression is nothing but, let's say, sine x. Let's say a sine x. Y equals to a sine x. This is one equation of motion. In that equation of motion, the particle is moving. Right? So there is a constraint that the particle should move in that, according to the nature of this equation. This is the first number of constant. What is the second number of constant? The second number of constant can be taken as like our z is 0. You can see like this is a 2D plot, right? Here x is there and y is there, and the particle should not move to the z direction. Z direction means it is like third dimension. You can come here and it will be outside of the paper or inside of the paper, something like that. So z should be 0 because our particle is constrained in a 2D space, and in the 2D space it is moving with a sinusoidal nature. So there is one constant is y equals to a sin x, and another constant is z equals to 0. Right? So there are how many number of constants are there? Number of constants are 2. K equals to 2. Now I already have the knowledge that n equals to 1 and k equals to 2 for that question. Then what will be the value of degrees of freedom? Degrees of freedom. So it is, I told you, 3n minus k. That means 3 into 1 minus 2. So it is nothing but 1. So the answer of that question will be 1 if a particle is moving in sinusoidal curve, the number of degrees of freedom of the particle will be 1. Okay, so I think it is understandable and it's a little bit simple, but you have to understand how many number of constant is present in your question. So in this question, one constant is coming from the sinusoidal condition, that a sin x, and another constant is coming from the z-axis, that z-axis is 0 value. Only it is in a 2D curve and there is no 3-dimensional space non-zero value. So these two constants are giving, and with the help of these two constants as well as the number of particle knowledge, we can get the value of degrees of freedom, which is 3n minus n. In this case, n is 1 and k is 2, so that's why degrees of freedom is 1. Okay, so I think it's understandable, and we will go to the next question. Where is next question? Yes, this is next question. This is coming from the 2019 question paper, and it is also on the topic of classical mechanics. Okay, so this is question number 47. So this question is a little bit tricky, not that much. So we will read the question very carefully, and after that we will do the answer. So what is the question? Two ships A and B, each of the same rest length L, are moving in the same direction with speeds 4c by 5 and 3c by 5 respectively, where c is the speed of light. As measured by B, the time taken by A to completely overtake B, see figure below, in units of L by C to the nearest integer is which? You can see here the picture. I will explain the question again so that you can understand the question very clearly. In that picture you can see, in the first picture A is there, B is there, right? And each and every length, each and every spaceship has a length L. A has length L and B has length L. And A is moving with 4c by 5 velocity, B is moving with 3c by 5 velocity. Now you can see, obviously if 3c by 5 is there for B, then A will move faster than B, right? So A is moving faster than B, because you can see that this is 3c by 5 and this is 4c by 5. Something is there, okay. So it is 3c by 5 and it is 4c by 5. The question tells us that you have to tell me at which time A will completely overtake B, and the time can be measured with the frame B. Okay, you can see here, as measured by B, the time taken by A to completely overtake B. Overtake B means, like, from here, let me tell, this is the first point and this is the second point, because you can see that's why the two figures are there. At the very first point, this is the first point, and here this is the second point, last point. So to overtake this whole L, how much time our A spaceship will take, which we are going to measure according to B spaceship. That is the thing. So, and we have to answer the question. We have to answer the question in the units of L by C, where L is the length of that spaceship and C is the speed of light. Okay, that is the thing. So now what we will do, we will just quickly write all the given values. You can see here whatever they have given that the speed of A and B are 4c by 5 and 3c by 5. That means U of A is 4c by 5, U of B is 3c by 5. And what also they have given? They have given, like, the length of A is L, the length of B is also L. These four things they have given. I think, is there anything else? No. These four things they have given. So first of all, what we need to calculate? We need to calculate that from the B spaceship, what will be the relative velocity between A and B. Okay. So if I tell relative velocity, there is an expression for the relative velocity between A and B, which we are going to measure from the B spaceship. That is given in the relativistic classical mechanics course, or as well as from Einstein's relativity theorem and all. So I am just going to write that one. Let's say I am giving this relative velocity as UAB, which is nothing but UA minus UB divided by 1 minus UA UB divided by c square. So this is what? This is the relative velocity of A with compared to B. That is the thing. So if I just put these things, you know that UA and UB is given, and if I right now going to put this, then it will be like 1 minus 4 into 3 by 5 into 5, and c square are cancelled out, so that means like that. Now you can see, if I just calculate a little bit, then it will be 1 by 5 divided by 1 minus 12 by 15. Okay, so if I write here c by 5 divided by 25 minus 12, nothing but 13. So c by 5 into 25 by 13. The result is 5 by 13 into c. So what is this one? This one is a UAB, relative velocity of A with respect to B, 5 by 13 c. So this is the relative velocity. In that, by that relative velocity, A is moving. A is moving in this side. B is also moving in this side, but A is moving with the relative velocity 5 by 13 c in the x-axis, positive x-axis compared to b, something like that. Now this is a relative velocity, but they are asking about the time in which A can fully overtake B. So how it will be? Let me tell you, UAB into T. What will be this one? This one will be nothing but a distance. Relative velocity into T, that is nothing but a distance. So this one is 5 by 13 into C into T. So this is the distance. Distance means what? That should be equal to the distance. I am writing here. This distance which is fully covered by B, I mean the B distance which is L, plus there will be length contraction because of the high speed. 1 minus UAB 1 minus V square by C square. So UAB whole square. So this will be the expression, and from this expression we know the UAB value, we know the L value, and we are just going to calculate the T value from this expression. So I am just going to write here 5 by 13 into C equals to L plus L into root over 1 minus UAB by C square, UAB square by C square. Because how this is coming? This is coming due to the length contraction. Okay. Yeah. So UAB was what? 5 by 13. Then after a small calculation, I can get 1 plus root over 1 minus 25 by 169, and C square are cutting. Then 1 plus, this is 13, this is 12, because it is 144. You can see it is 169 minus 25, it is 144, and 144 root is 12. So it will be 13 and this is 25, because 13 plus 12. Right. So 5 by 13 into C into T equals to, what is that? L into 25 by 13. Yes. Yes.
No, I don't understand how you arrived at this equation. Can you
explain? Okay. So did you understand that what is UAB? UAB is nothing but the relative velocity. I am just going to clear this picture. I have done so many things here. So in that question they are asking that how much time it will take to overtake B, and the time will be measured from B itself. Okay. So what we will do, we will first calculate UAB. UAB is what? It is the relative velocity of A with respect to B. So UAB is relative velocity of A with respect to B, and we have calculated UAB, and the result is like 5 by 13C. So this is the relative velocity, but in that, with that speed A is going with respect to B. That is the thing, right? So now they are asking about how much time it will take. So time means what? If I calculate, let's say 5 by 13 into C into T. So this is what? This should be the length distance which will be covered by A in that duration of time. So our T is nothing but the time at which A can fully overtake B. Okay. So A can fully overtake by B. A can fully overtake B with the help of this time T. Now if I going to calculate the T value, what we will write? We will make some equation so that from that equation we can get the T value. So in that equation, so what will be the equation for this measurement of T? 5 by 13 into C. Okay. Five by 13 into C. This is the time. This is the length which will covered by A to overtake B. Now we have to tell me how much length we have to cover to overtake B. First of all, one length is full B, because you can see from that picture that in the first figure and in the second figure, the first figure you can see the starting point is here, and the second figure the last point is this one. So this, from this point to this point you have to cover, you have to overtake. That means our length will be obviously L, which is the length of B, but there will be something addition. What will be the addition? Addition will be nothing but the length contraction due to the relativistic speed of A. Okay, so that's why there is one expression that 5 by 13 into C into T, this is the required length to overtake B. Okay, and this should be equal to this should be equal to L, which is the full length of B, plus L into root over 1 minus V square by C square, which is nothing but the length contraction coming from the relativistic speed. Do you got the point? So the length should be total length plus the length contraction point, I mean the length contraction term, and this whole length should be covered with the help of V into T, and where V is the nothing but the relative velocity of A with respect to B, and then it should be multiplied by the T time, and that this time we are going to measure. Is it understandable, or should I tell you again?
Yes, ma'am, it is understood.
Yes, ma'am,
I understand.
Okay, so with the help of this one, I will just calculate what is the value of T here. I got one expression 5 by 13 into C into T equals to L plus L into root over 1 minus 5 by 13 whole square into C square divided by C square, something like that. So if I calculate, then I can get this expression, and from that expression I can also see the T value. T value is what? 25 into 13 divided by 5 into 13 into L by C. Now you can see, if I just calculate this, then it will be 5 into L by C. This is T, our time which is required for overtake B fully, and this time is measured in the frame as measured by B. So, and the result is like T is 5 L by C, and they are asking that you have to write the value of that integer in units of L by C. So L by C, so that means the result will be 5. So the correct T will be 5 second. Obviously, like the unit they did not mention, so you can say like second or something. So the answer will be 5. I think it's understand. Now we will go to the next question. Okay, so in that next question, what we will see, the next question will be from GATE 2019 physics question paper, and the question is 54, question number 54. It is also basically related to relativistic classical mechanics, so that's why I have just put that one simultaneously, this one and this one. Okay, now let me read the question first, and after that we will tell. Two events, one on the earth and the other one on the sun, occur simultaneously in the earth's frame. The time difference between the two events, as seen by an observer in a spaceship moving with velocity 0.5 c in the earth's frame along the line joining the earth to the sun is delta t, where c is the speed of light. Given that light travels from the sun to the earth in 8.3 minutes in the earth's frame, the value of mod delta t in minutes rounded off to 2 decimal places is how much? And they have given some hint that take the earth's frame to be inertial and neglect the relative motion between the earth and the sun. So this is the little bit assumption, something like that, and they are just wanted to know what will be the value of delta t. And what is delta t? Okay, so I am just writing here a pictorial representation so that you can understand. This is, let's say, earth. Okay, and this is one spaceship, yeah, ish, no, spaceship, yeah. So two events, and there is like somewhere a sun is there or somewhere. So two events are there. One event happened on earth and another one happened on sun, and these two are happened simultaneously in the earth's frame. Like if I just measure these two events from earth's frame, frame of reference, then you can see that this event and this event are occurring at the same time. Simultaneously means same time in the earth, I mean according to the earth's frame. This, let's say this is first, this is second. So first event and second event happen simultaneously. Okay, but obviously due to the relativity, at the space-time frame of reference, these two events will not be simultaneous, right? And we have to tell what will be the difference between these two events time with respect to spacecraft or something, spaceship frame of reference. That we have to tell. In earth reference, these two events are simultaneous, but we have to tell that in according to spaceship frame of reference, what will be the time difference between these two events. And there is some some information is given, like the spaceship is moving with the velocity of 0.5 c, and there is another information that the light travels from the sun to the earth is, the time is 8.3 minutes. That is the thing. So it's very simple that we have to tell what will be the time difference between these two events according to spaceship frame of reference, when in our earth's frame of reference these two events are simultaneous. Okay, I hope the question you can understand clearly. Now we have to tell me the answer. So let me first write all the references what it is given here. So first of all, it is given that I am talking about Earth's frame of reference as T1 prime and T2 prime. These two events was made simultaneously. That means T1 prime is equal to T2 prime. Delta T prime equals to 0. And we have to tell what is the value of delta T. Right? And the required expressions are given here, that velocity is 0.5 c. Velocity of spaceship is 0.5 c. And another one is there, that given that light travels from the sun to the earth is 8.5 minutes. So the time for light to travel from sun to earth, it is 8.3 minutes. Okay. So first of all, we will write the relativity expression for the T1 and T2. So you all know that T1 prime is T1 minus Vx 1 by c square 1 minus v square by c square, right? Similarly, T2 prime is T2 minus Vx2 by c square 1 minus v square by c square. Now in that question they are asking about delta T. So what we have to write here? Delta T means T2 minus T1. So T2 minus T1 if I write, then what it will be? It will be like T2 prime plus Vx2 prime by c square 1 minus v square by c square plus minus T1 prime plus Vx1 prime by c square 1 minus v square by c square. Now you can see here x1 prime and x2 prime are unknown for us. In this question T1 prime and T2 prime is given, which is nothing but T2 prime is equals to T1 prime and delta T prime is 0. This expression it is given here, but we don't, and also we know that V equals to 0.5 c, but we don't know about x2 prime and x1 prime. What will be the value of x2 prime and x1 prime? These two value can be extract from that condition that the time for light to travel from sun to earth is 8.3 minutes. So how we can get the value of x1 prime and x2 prime? So delta x will be nothing but 8.3 into, this is the time, so the time and then 3 into 10 to the power 8 and then 60, and it will be in second. I mean this one and this one will give in second, and this is nothing but the velocity which is meter per second. So that means our delta x which is delta x prime, it will be 8.3 into 3 into 10 to the power 8 into 60. Okay, so now we got the knowledge of delta x prime also. Now we are just going to put all the values in the expression of delta t. So I am just going to write here, you can see that 1 by root over 1 minus v square by c square can be common out, right? So I am going to common out this one, 1 by root over 1 minus v square by c square, and then t2 prime plus vx2 prime by c square minus t1 prime minus vx1 prime by c square. Now what will be the answer for this? 1 minus v square by c square. Then you can see t2 prime minus t1 prime. t2 prime minus t1 prime is 0 because these two in the earth's frame of reference were simultaneous. So it is 0. Now v by c square and x2 prime minus x1 prime. So you can see that this is nothing but delta x prime, and delta x prime, we have the value of delta x prime from this expression. Now we are just going to put the value here. 1 minus 0.5 by c whole square, and then this is like v by c square. V was 0.5, so I am just going to write here 0.5 into c, and then x2 prime minus x1 prime, that is nothing but delta prime, delta x prime. So delta x prime I can see it as c, so 8.3 into 60 into c. So if I just calculate a little bit, then it will be like, I'm not going to calculate that one explicitly, so it will be like 4.77 or something. It will be 4.77 in minute. How it, I mean here it is in second, but if you just do that one little bit, then it will be like it is in minute, and it is nothing but 4.77 into 60 second. So you can have the knowledge that what will be the value of delta t. The delta t will be 4.77 minute, and I think in the question they were asking about in the unit of minute. Yes, delta t in minutes, and it will be rounded off to 2 decimal places. So that's why our result is 4.77 minute. Okay, so for that question, what we need? Only we need the knowledge of the relativity expression, that is delta t prime and delta t, and we need delta x prime value, as well as we need the value of v. So just putting these values, we can have the answer that delta t is 4.77. Now I just want to tell you one thing. Just remember the question again. In that earth frame of reference and in the spaceship frame of reference. In that earth frame of reference, t2 prime and t1 prime was exactly same. That means delta t prime was 0. But in the spaceship frame of reference, you can see t2 is not equals to t1, and there is a little bit delta t value, which is nothing but 4.77 minute, right? So that means due to the relativity, our two events are not simultaneous in the according to the spaceship frame of reference, but it is simultaneous in Earth's frame of reference. So this is the case. I think it's understandable, or do you have any? Oh, this is not T2, this is T1. If you have any question, you can ask me, or we can move to the next question. Okay, we will move to the next question. Okay, so this question is from GATE topic classical mechanics 2021 physics question paper, and the question number is 20. Okay, now this is totally hardcore classical mechanics, right? A hoop of mass m and radius r rolls without slipping along a straight line on a horizontal surface as shown in the figure. A point mass m slides without friction along the inner surface of the hoop, performing small oscillations about the mean position. The number of degrees of freedom of the system in integer is how much? Okay, so you can see the picture. I am just going to explain the question again so that you can understand clearly. This is the hoop. It is already given in that question. This hoop has a mass m and it has a radius r. It rolls without slipping, okay, along a straight line on a horizontal surface as shown in the figure. You can see that a point mass m, one small point mass, which it slides without friction along the inner surface of the hoop, performing small oscillations about the mean position. There is a very small oscillation about the mean position. The number of degrees of freedom of the system is what? Now you can see, okay, so I told you that for number of degrees of freedom we need to know how many number of particles are there and how many number of constants are there. So here you can see that the number of particles are here 2, like as a system there is 2 particles. But okay, so the number of degrees of freedom can be also explained with the definition that how many degrees of freedom, I mean how many the number of degrees of freedom can be defined as like how the nature of the system is. You can see in that system only 2 types of motion are there. One is fully translational and another is fully rotational. Which one is the translational and which one is the rotational? You can see here that this one is fully rotational, which is m, and the small m is fully translational, because you can see the point mass m slides without friction. There is no friction, so if there is some friction then there will be some constant, but there is no friction, so there will be no constant from that frictional force, but it is a purely rotational motion for purely translational motion for small mass m, and for capital mass M it is purely rotational, because you can see that our M is rolling without slipping. If there will be some slipping, from that slipping also there can be some constraint coming, but as it is purely rotational and purely translational for small m, the degrees of freedom will be simply 2. Okay, as the motion are little bit totally purely rotational as well as translational. Rotational is for capital M, translational is for small m. So by the knowledge of the nature of that system, nature of the particles movement, we can tell that the number of the degrees of freedom for whole the system is 2. One is coming from translational motion. I am just going to write here a little bit. Translational motion of small m mass and rotational motion of capital M mass. So this is 1 degrees of freedom, this is another degrees of freedom. As a whole, our degrees of freedom can be written as 2 for the whole system. If there is some friction or there is some slipping for that small m as well as capital M respectively, then we can have some constraint and after that we can have some different value of degrees of freedom. But here, as there is totally purely rotational and translational motion, so that we can tell the number of degrees of freedom of the system is 2. Okay, so I am just going to for the next question. Okay, so the next question is from GATE 2021, and the question is this one. This is question number 39. The question is, consider a spherical galaxy of total mass m and radius r having a uniform matter distribution. In this idealized situation, the orbital speed v of a star of mass m, where m is very less than capital M, as a function of the distance r from the galactic center, is best described by which plot, where g is the universal gravitational constant. And there are 4 options of these plots. You can see this is 1, 2, 3 and 4. So in that question they are asking that consider a spherical galaxy. There is a spherical galaxy of total mass m and radius r having a uniform matter density distribution. So if it is a uniform matter distribution, then there will be no problem with that matter integration and something. In this idealized situation, the orbital speed v of a star, this is the orbital speed of that star m, which is very less than m, as a function of the distance r from the galactic center, is best described by which expression. And the plot is nothing but between r and v. For each and every situation you can see the plot is between r and v. So the main aim of our answer is like, we have to produce one expression as v function of r. Sorry. If by anyhow we can have one expression which is v as a function of r, then only we can have some plots with the help of this condition, this expression, right? So first of all, as it is a spherical galaxy with mass m and radius r, we can have definitely one thing which is nothing but er. It can be written as, let's say, gm by r cube when r is less than r, right? And we can also have another condition, that gm by r square when r is greater than r. It is obviously coming from that simple Kepler formula and all. So here can have 2 values. One is gmr by r cube when r is less than r, and gm by r square when r is greater than r. Now as it is telling that our small m, which is very less than m, it is moving with the velocity v, then what will be the condition of this case? mv square by r will be gm m r divided by r cube for first condition, that r is less than r. And the second condition is mv square by r is equal to gmm by r square when r is greater than r. These 2 conditions will be satisfied simultaneously. One will be r less than r, one will be r greater than r. So now, as we got one expression for this v and r, gmm r by r cube, r less than r, then from that expression we can definitely tell what will be the expression of v in terms of r, right? How? You can see here, if I just calculate these things, then it will be like v square by r equals to gm r by r cube, and then v square will be r square gm by r cube. So from there you can see v square is proportional to r square. All the things are constant here. Let me tell you, m and r are constant here. Like there is a specific value of m, the mass of the galaxy, and the specific value of r, the radius of the galaxy. So v is proportional to r. In which condition? When r is less than r. This condition. Now coming to the second condition, m v square by r is, I think it is gmm by r square. I think this one is that one, yes, gmm by r square when r is greater than r. So from that expression you can tell v square by r is gm by r square. V square is gm. No, I think something has missed. Oh, sorry. People did not tell me. It is r square, small r square, because this is the e function of r, right? So it will not be capital R. So it is small r. Yeah, it's a mistake. So this is the first question. This is the second condition, that r will be there, small r will be there. So that's why I thought that where r is going there. So v square is gmr by r square. Now you can see v square is proportional to 1 by r. Now v is proportional to 1 by root over r. In that condition, which condition? When r is greater than r. Now we can summarize these two as v is proportional to r when r is less than r. V is proportional to 1 by root r when small r is greater than r. These two conditions we got from that from the knowledge of this question. Now we have to plot these two. Now you can see simply, if I just write here, r is there and v is there. So let me tell you, this is, let's say, r equals to r. I mean small r equals to capital R. So at that point, yeah, so this portion is nothing but r is less than r, and this portion is small r is greater than capital R. Then if small r is less than capital R, then you can see that we have the expression v is proportional to r. That means it will be nothing but a straight line. V is proportional to r, right? And now in the right hand side of that picture, from this point, it will be 1 by root over r varying. So 1 by root over r being varying means obviously it will be a decreasing function, like that, right? So we have to match our result is like this. V, this is r, and we have to see that which one is the correct one. Yes, see this one. There is the first option which is giving like linearly increasing, then there is 1 by root over r decreasing function. So the correct answer for this case will be A. So this is the case. Okay. So for this class I just made 5 questions. So if you have any question, you can ask me regarding these 5 questions. I am just going to show you these 5 questions exactly. So this is the first question, that if a particle is moving a sinusoidal curve, the number of degrees of freedom of the particle is how much? And you can see that the result is coming as 1. 3 minus 2, which is nothing but 1. Now this is the second question. In that second question you can see GATE 2019 question paper, and the question number is 47, and here these 2 pictures are given, and from that picture we have to tell me what will be the value of the time in which our A can overtake completely B, and the given parameters are like 4c by 5 and 3c by 5, the velocities of A and B, and also I think the length of the spaceships are L. Both has the space length L. So this is the question, and as we got the answer is 5. I mean 5 L by C will be the time, and if they are talking about the unit of L by C, then it will be 5. So then next question, yes, next question is this one, that two events are there and we are seeing the two events from the earth surface, and it is simultaneous according to earth surface, but according to the specific frame of reference, what will be the delta T value, that we have to tell, and the result is like 4.77 minute. If I just put these values a little bit, then it will come as 4.77 minute. So this is the time difference of these two events according with respect when we are just seeing these events from specific frame of reference. So I just told you with the picture, that is the. Then in that next question, yes, in the next question you can see one hoop is there and its mass is capital M with the radius capital R, and a small mass particle M is sliding without friction of the inner surface of the hoop, and the hoop is rolls without slipping. So there are two motions are there. One is translational motion and another one is rotational motion. Translational motion is due to the small m and rotational motion is due to the capital M. So the number of degrees of freedom of the system will be 2 in integer. One is translational and another one is rotational. So the last one is, yes, the last one is consider a spherical galaxy of total mass m and radius r having a uniform matter density. In this idealized situation, the orbital speed v of a star of mass m is very less than capital M as a function of the distance smaller from the galactic center is best described by which plot, and here g is a universal gravitational constant. So from that case we just got a expression that the expression is in between v and r, the velocity of the star with respect to the distance. So we got a relation that v is proportional to r when r is less than capital R, and v is proportional to 1 by root over small r when r is greater than capital R. And if I just plot these two, then it will come as option number A. So that's why the option number A1 is the correct one. So for that what we did, why we just put the ER value. ER is GMM R by R cube. It is coming from the spherical nature of that galaxy in the condition that R is less than capital R, and it is also coming that GM by small r square when R is greater than R. Then we are just putting these values for that gravitational force expression, that mv square by r equals to GMM R by R cube, and mv square by r equals to GMM by r square. Then with these two conditions we got the expression for v in terms of r, for r less than small capital R and small r greater than capital R. So this is the case, and then I got that answer. Yeah, so I just yeah.
What is E of R here?
What is
E of R?
So this is what? Can you tell me? GM by r square. What is the expression for this one? It is very much equal to which one?
I think it's counterpart of electric field.
Field, gravitational field.
It's gravitation field.
So like I did not derive this expression, because you know that when a spherical cell is there, let's say spherical galaxy is there, galaxy or anything, let me tell you, it is like spherical cell or something, then if there is like small capital R is there and I am going to calculate the electric field at the value of R, then there will be some condition, like if R is less than capital R and R is greater than capital R. So if R is less than capital R, then there will be one expression like Gm small r by R cube. It's a very similar way we are calculating, because like in that question they are asking that this is a spherical galaxy. So we can assume for a spherical case what is the condition, and we are just putting the same condition for the spherical galaxy also. So here you can see that the gravitational field is nothing but gm r by r cube for r less than capital R, and for gm by r square it is r greater than capital R. So if I just calculate these two with the help of that spherical condition, then we can calculate the rest of the things, that ER into m and ER into m for mv square by r, mv square by r. Okay, so this is very simple, like why we can, I mean how we can directly write these expressions, because of the spherical cell problem. So in that spherical cell problem you can see that if it is like capital R, and let's say I am calculating here the electric field, then what, I mean the gravitational field, then what will be the value of that ER. So I am just directly putting this expression here, because they are considering here spherical galaxy of total mass. So spherical means we do not need to bother about any distortion on that galaxy and all. Okay, so that I can directly write these expressions from that spherical nature, I mean spherical knowledge, spherical cell knowledge. And after that, after writing these things, I can write this one, that mv square by r. Mv square by r is what? It can come from that your Newtonian force law, so you can see that mv square by r is gmm, like nothing, it is nothing but er into m, the gravitational field into m. Then here also you can see that er into m, so that we can have mv square by r expression, and from that in the different two conditions we can have the expression of v in terms of r. One is proportional to r and another one is 1 by root over r. And with the help of these two knowledge I can get that type of plot. Okay, so this
Yes,
is
ma'am.
actually I mean everyone can write this one directly because of the knowledge of that spherical cell problem. As in that question it is clearly mentioned that our galaxy we are taking as spherical, so that's why we can write that one. Otherwise there will be some problem, but we can definitely write because it is already given in that question that it is spherical galaxy. Okay. So then any other question or something, or we can see in the next class. I think in next class it will be thermodynamics maybe. Yeah, so we will discuss about